Photoelectric effect and photoelectric cell. Photoelectric effect. The photoelectric effect refers to the emission or ejection of electrons from a metal surface in response to incident light. Energy contained within the incident light is absorbed by electrons within the metal, giving the electrons sufficient energy to be knocked out of or emitted from the surface of the metal. Einstein in 1905 proposed that the incident light consisted of individual quanta, called photons, that interacted with the electrons in the metal-like discrete particles rather than as continuous waves. For a given frequency or color of the incident radiation, each photon carried the energy E is equal to h nu, where h is Planck's constant and nu is the frequency. Albert Einstein was honored with the Nobel Prize in Physics in 1921 for successfully explaining the photoelectric effect. Photoelectric cell. The photoelectric cell, also known as phototube, is an electron tube in which the electrons initiating an electric current originate by photoelectric emission. A phototube consists of a cathode coated with a photosensitive material and an anode. Light falling on the cathode causes the liberation of electrons, which are then attracted to the positively charged anode, resulting in a flow of current proportional to the intensity of the incident radiation. Phototubes are either evacuated or filled with an inert gas at low pressure to achieve greater sensitivity. If a series of metal plates are arranged in the electron tube, then the photoelectric emission is amplified by secondary electron emission. This type of tube, where there are a number of tubes, is called a photomultiplier. The photomultiplier is capable of detecting radiation of extremely low intensity. Hence, it is used as a radiation detector in nuclear research. Applications of photoelectric cell. The photoelectric cell, popularly known as the electric eye, is employed in photosensor motion detector used in burglar alarms, traffic light controls, and automatic door openers. Various types of phototubes are used in sound recording, television, and in scintillation counters. Photosensor motion detectors are the devices you see in a store at a shopping mall. When somebody enters the store, the motion detector sounds a chime or bell. The two components of a photosensor are a source of focus light and a light sensor. In a home security system, the light produced by a bulb at one end of the circuit falls on the phototube located some distance away, and electrons are emitted by the cathode. When somebody walks between the light source and the sensor, the path of the beam is blocked briefly. The sensor registers a drop in light levels and sends a signal to the control box. The control box, in turn, is connected either to a siren, flashing outdoor lights, or to a telephone autodialer.